So in this video, I'm just going to go through some examples of nucleophiles and electrophiles with respect to organic chemistry. And nucleophile-electrophile interactions and reactions are a huge part of classifying different types of reactions. So it's really essential that we can distinguish what's a nucleophile and what's an electrophile. So nucleophiles are termed this way because they are nucleus-loving, and the majority of these will have anions, and these can be atoms with a negative charge, like bromine, or they can be something like hydroxide, which also carries a negative charge, and it makes for a great nucleophile. And even something like cyanide. Cyanide has a triple bond, but it does have these lone pairs on the carbon that give it, there's one lone pair on the carbon that gives it this negative charge. And those lone pairs that allow for that negative charge is what's going to do the attacking onto an electrophile. Now, another category within nucleophiles are those molecules with pi bonds. And those molecules with pi bonds would include alkenes, so something like this. Alkenes certainly can serve as a nucleophile, and even an alkyne, something like this. And benzene for sure. Benzene has 3 pi bonds, and any of those 3 pi bonds can serve as attackers onto electrophiles. Now, the last category I want to go through for specifically nucleophiles are those molecules with lone pairs, but not necessarily a negative charge. So that would be something like water, something like amine or amide. These lone pairs are really what's giving them that nucleophilicity. So CH3, these are lone pairs on this carbonyl. Now we're going to see later that carbonyls can also serve as electrophiles, but when we're looking at nucleophiles, these lone pairs are what's going to give it that nucleophilicity to attack something else. But we're going to see that usually when a carbonyl is attacked, it's going to be attacked from the backside, and the backside is what gives it the electrophilicity versus the nucleophilicity. So now that we've gotten those examples down, I'm just going to go ahead. All right, so now we're going to be focusing on electrophiles. So electrophiles are the other half of our reaction, and these electrophiles are usually going to be, so they're electron loving. So that's important to remember because nucleophiles usually have electrons to attack another molecule. So electrophiles love those electrons. That's why they take them. All right. So electrophiles are usually going to be those with a positive charge, those molecules with a positive charge, or those that are positively polarized. All right. So when an electrophile accepts an electron pair to form a new bond, that is the job of the electrophile. So essentially, to give you an example, a well-known example, is a carbonyl. So a carbonyl has a dipole moment for sure, and the dipole moment goes like this, indicating a little bit of negative charge over here and positive charge over here. And what happens is this positively charged region is prone to nucleophilic attack from electrons. So since it's partially positively charged, it attracts electrons, which are negatively charged. And electrons are found on nucleophiles. So that's what really makes carbonyls, when attacked from the backside, great electrophiles. Now we're going to do a few comparisons about what's a better electrophile and what's still an electrophile but not so good. So when we have something like a molecule like this, now we know that carbons usually have 4 bonds, but in this case, this molecule doesn't, so we would have to put a positive charge there. There's that, and now I'm going to draw this molecule. Alright, so now this has a partial positive charge. Let me draw bromine here. So this would have a negative charge, but this carbon has only a partial positive charge just because of that dipole moment on the bromine, right? So in that case, this partial positive charge is not as good as a full real positive charge. So this molecule would make a better electrophile if we were comparing it to this molecule. Now, that's pretty much the basic examples of nucleophiles and electrophiles. Another important thing to remember is that nucleophiles are often basic. They're often bases, and electrophiles are often acidic. This makes a lot of sense because the proton is removed in bases, which allows for that negative charge to persist. So that's pretty much all I wanted to go through for just a few examples of nucleophiles and the overall concept of an electrophile. And I'll see you guys next time. See ya.